We're about to dive into a topic that's, well, it's right at the crossroads of some seriously mind-bending physics and the entire global economy. It's called quantum computing. And believe me, it's about to become both the greatest opportunity and maybe the biggest threat finance has ever had to deal with.
So, let me just start with a question for you. What if there was a single key, a key that could unlock, on one hand, unimaginable wealth and solve some of our most complex problems, but on the other hand, could also bring our entire digital world crashing down?
You know, that's not some sci-fi plot. That key is literally being built in labs all over the world as we speak. It's quantum computing. And trying to understand it? Yeah, that's not really optional anymore. It's absolutely essential.
To really get why we even need this new key, we first have to talk about the walls our current tech has slammed right into. The hard limits of finance as we know it today.
I mean, the supercomputers that power Wall Street are incredible, right? They're doing trillions of calculations every single second. But even they have a breaking point. There are certain problems in finance that are just so complex, with so many moving parts, that our best machines, they just hit a wall. They can't go any further.
What kinds of problems are we talking about? Well, think about trying to create a perfect simulation of the entire market to see a crash coming before it happens, or running risk models that could account for every single possible event around the globe, or figuring out the truly perfect optimal portfolio out of millions of assets. These things aren't just hard. For the computers we have now, they're basically impossible.
And this is where that quantum leap comes in. See, it's not just about building a faster computer. No, it's about building a fundamentally different kind of computer, one that, thinks in a completely new way.
So every single computer you've ever used, your phone, your laptop, even those giant supercomputers, it's all built on one simple idea, the bit. Just think of it like a light switch. It can be on, which we call a 1, or it can be off, a 0. That's it. Simple, it works, but it's limited.
Okay, now let's look at the quantum version, the qubit. Instead of a light switch, I want you to picture a spinning coin. Now, while it's spinning, is it heads or tails? The weird answer is, it's kind of both. And this bizarre property of being in multiple states at the exact same time is called superposition. And that is where a quantum computer gets its incredible power.
To really see the difference, imagine you're trying to solve a giant maze. A classical computer would try one path, hit a dead end, turn around, go all the way back, and then try another path. It has to check every single path, one by one by one. But a quantum computer, using superposition, it can explore every single possible path through that maze at the exact same time. It's a leap in power that's almost impossible to wrap your head around.
So, with that kind of mind-blowing power, what can we actually do with it? This gets us to the first side of our double-edged sword, the incredible promise of quantum finance.
Let's look at a real-world example. Right now, a big bank might run this hugely complex risk analysis, and it could take weeks to finish on a supercomputer. Of course, by the time they get the results, the market's already moved on. A quantum computer could take all those same variables, interest rates, political chaos, supply chains, you name it, and analyze them all at once, giving them a way more accurate answer almost instantly.
Take a look at this number, 2.5 trillion years. That is how long it would take the most powerful supercomputer on Earth to solve certain really tough problems. A quantum computer, down the road, could potentially solve that same exact problem in a few minutes. That's not just an upgrade, that's a whole new reality. And the possibilities are just staggering. We're talking way beyond just market predictions. This power could let us design entirely new financial products to protect against risks we can't even measure today. And it spills way outside of finance. I mean, imagine optimizing global supply chains in real time to stop shortages before they start. Or, for biotech investors, simulating molecules to find life-saving drugs faster. This is going to be economic disruption on a massive, massive scale.
But every revolution has a dark side. So now we have to flip the coin and look at the other edge of the sword, the part that keeps cybersecurity experts staring at the ceiling all night, the peril.
The term crypto apocalypse sounds super dramatic, I know. But if you talk to people in this field, they'll tell you the threat is very, very real. It's the day our entire digital world could just go dark.
The weak spot, the vulnerability, is in something called public key cryptography. You can just think of it as the master lock that protects pretty much everything you do online. Your banking passwords, your private emails, secure government secrets, all cryptocurrency. It all depends on this one kind of digital lock.
And here is the absolutely devastating problem.
These locks are built on a math problem that is incredibly hard for our normal computers to solve. But, and this is the crazy part, that exact same math problem is something a quantum computer is perfectly designed to solve with terrifying ease. So the very thing that keeps us safe today is the very thing that makes us completely vulnerable tomorrow.
So what's actually at risk here? Well, everything. The data for every single bank account, the integrity of the whole stock market, every Bitcoin and crypto wallet in existence, and even more fundamental, your entire personal digital identity. If these locks break, the system as we know it breaks.
And that brings us to right now, which is basically a frantic, high-stakes race. It's not just a tech race, it's a geopolitical one. You've got countries all over the world fighting to be the first to get this incredible strategic advantage.
On one side, you've got the offensive race. Nations and companies are pouring billions into building a quantum computer strong enough to break all our current encryption. And on the other side, you've got the defensive race. Cryptographers working like crazy to design a whole new generation of encryption called post-quantum cryptography that even a quantum computer can't crack.
This timeline really shows you how urgent this is. We are right here, in the first stage. The vulnerability is real and the race is on. Very soon, these new quantum-resistant algorithms have to be rolled out, and that leads to the hard deadline. The entire global financial system has to upgrade all of its security before a big, powerful quantum computer shows up.
It all boils down to one absolutely crucial point. For the stability of our economy, for our digital lives, the defensive race to build new, stronger locks has to be won before the offensive race to build the master key is over. The stakes just couldn't be any higher.
Look, there is no doubt about it. The quantum revolution is coming. It's going to reshape our world in ways we can probably barely even imagine right now. But it leaves us with one final critical question. Will we be ready to control what we create?